Okay, last another 1 minute. We start. Okay, class. Okay, I think about 6 or 7 of you. Okay. Today also we try to finish off this topic. Okay. I think tomorrow after we finish this, I think we're going to start our. Do you receive anything from the college? Any update?
No, I don't think so.
Yep.
I don't think so.
Sorry. Hold on. Let me get the volume. You receive any updates?
From yesterday till today, no.
Oh, that means they finalized the trial. Do you? No. So you're not sure there is a trial?
I thought it was 100%. When you told me yesterday that it's not 100%, then I was like, oh, okay. Yeah, we thought it was 100% going to go on.
With what trial is it?
Yeah.
So what they said is going to be like a 50%.
No, they just said that they will, if it goes on, I don't know if it's happening, but it will happen in May, June, the 13th of May to 3rd of June. And they will send our scripts or something, our mark scripts to Cambridge, and then Cambridge will give us a grade accordingly.
So it's going to be like an 100%, right?
Yeah.
Yeah, that's the plan, I think. But still, they are waiting for the reply. I think today, it's supposed to be today. Today they're supposed to receive the letter. See what is the outcome. Okay, so today let's continue with what we've done. Okay, you can see the PowerPoint again, right?
Yeah.
Okay. Okay, so everyone, recall back what we learned last class. Okay, so we learned about energy and potential energy, kinetic energy. Okay, and kinetic energy become maximum at the center or at the edge. Kinetic energy is become maximum at the equilibrium. Kinetic energy maximum at equilibrium. Potential become maximum at the edge. Okay, then we come across with the kinetic energy formula. Okay, so half m omega x naught squared x squared. Okay, and the graph going to be a quadratic, and its time is going to be a what squared graph. That at the center. Okay, another one I need to emphasize is this one. EK max. EK max, EP max. Okay, EK max, EP max.
Sir?
Yeah.
Didn't you send the link to the other class? Because they're like asking, why isn't there?
Every time I need to invite them. Oh, the other class, they never received it.
Yeah, they all don't have the link.
Oh, is it? Okay, I have to go back, I think.
Yeah, invited by Rachel.
I think I forgot. uh, Let me connect back. The other class. Oh, I forgot. Okay. Let's give another 2 minutes. Okay, now I think the new safety features, I think I need to admit every time, one by one. Okay. Visual NG. Okay, Jiong is here. Okay, so I think the new feature is like every time when a new participant, so I have to go and admit them. So I think the best is like when I give the link, I think I wait for 5 minutes. So try to get in, then we just start.
Morning, sir.
Yeah, morning, Jim. Yeah. So how's the days? Hey,
Not really.
life is good at home. Everyone love to stay at home, but now become like everyone want to stay at home.
Sir,
Huh?
admit Xisheng in.
Yeah,
Yeah. Admit her.
admit already. Yeah. Now I think even if you have a very high fever, also you like to go to college. I think here in future.
I don't want to stay at home.
Oh, you don't want to stay at home. Not only you, everyone.
It's so boring.
Yeah, so bored. Okay. Okay, but it's okay. Thanks for the virus restoring back the nature.
Yeah.
Yeah.
Air pollution get decreased.
Clear.
Also, so we will have mock tests at mid-May. So
Admit me, yeah. Admit me, Okay, class. You see the names, please type in your actual name, so easier for us for the attendance, Okay. So if your name is not actual name, then it's very difficult to capture in the attendance. Okay, write your name. Okay, let's go back.
we prefer to watch your YouTube video instead of the live.
Live,
So I go to watch your YouTube video instead of coming to here.
Okay. So
You still need to take my attendance for every lesson.
You have to take attendance because we have to show to the office who are attended, who are not attended.
It's okay. You go to your YouTube channel and check whether someone called Jehong.
Yeah. Okay, so let's restart. Okay, be just about to finish this topic. Okay, if anyone new entry, please remind me now. Then I go and admit them. Okay. So I think I forgot to say this last class. Okay, you can see the PowerPoint. The E max, EP max, and E total. Okay, another one is what? The E total. Okay, EP max, E total. All these three quantities are linked to the same formula. Okay, all of them are half m omega squared x naught squared. Okay, they ask E total. This is the formula. EK max, the same formula. EP max also the same formula. Okay, half m omega squared x naught squared. If you want EK at a given displacement, then you use this formula, the top one, with the displacement. X is there. Okay. Okay.
So someone is waiting for you.
Yeah.
You click manage participant. Yeah.
Admit. Okay.
So inconvenient. Oh my god.
Every time need to admit. So I think better everyone come in 5 minutes. First 5 minutes easier. Is it admitted? Not admitted. I'm clicking, but it's not working. Admitted. Yeah. Okay. So EP max, EK max, and E total is the same formula. Okay, let's move on. Okay, that day I told you like I have to go back. I need to go for one question before we continue. I show the question first. Okay, the question is this. Sorry. Okay, I go for one pass here. Okay, this is the paper. Okay, it's already posted. Okay, hold on, sorry. Okay, so let's we do together. I want you to give a try one question. This is the pass here. Okay, the question is this one. Sorry. Yeah, this one. Okay, okay, this is the question. This is November 03. Okay, let's we do together. So far, what I taught you, what if you learned. Okay, so you can see the question, right? Everyone? Okay. Okay, the first one. Okay, you can see the question there. Okay, so first, defining the equation simple harmonic motion. A is negative omega squared x. Identify the symbol in the equation. A stands for what?
Acceleration.
Acceleration. Omega is angular
Frequency.
Velocity.
you don't say angular
displacement.
angular frequency. Yeah, you have said angular frequency, not angular velocity. Angular velocity. X is displacement. Okay, next to state the significance of negative.
Opposite direction.
So the acceleration is opposite direction to the displacement. Okay. Okay. So here you have a system. Okay, it's a trolley with a 2 spring. Okay, at the side, they're asking, show that the magnetic force, the restoring force acting on the trolley is given by F equals to 2 kx. Okay, how do you can get F equals to 2 kx here? Okay, the trolley is then displaced a small distance of x. Okay, the trolley has been displaced. The trolley was now shifted to the right, let's say, from this point to the new position is x. Okay, x. But originally it was in extension of E. Both of them in the extension of E. So if you shift this trolley to the right, what is the new extension here now? How much? E. Originally was E. Now is how much? E
2E.
2E. E plus x.
X.
E plus x, right? The left spring is E plus x. On your right spring, what is the new extension? E. Anyone? Because the
E minus X.
yes, it's a E minus x. E minus x. Okay. So now, sorry, there is a new participant. Let me admit all. Okay. Okay. So this is E plus x. This is E minus x. Okay. Now they're asking, find the restoring force is F equals to 2 kx. Okay. Now tell me, this is the equilibrium. This is the equilibrium 0. The trolley has been shifted to the right. So the restoring force must be to the left or to the right. Should be to the left, right?
Left.
Restoring force. Okay, what is the net force of the trolley at the new location here? There is a force to the right. There is a force to the left. The force to the right is caused by this first spring. Okay, the force to the right is caused by the first spring. The force to the left is caused by the second spring. This is the second spring.
Right spring.
Okay, so which force is bigger? Right spring bigger. What is the net force? Can you find the net force? The net force is, the restoring force is the net force. The net force is what? What force equals to what force? F1? F1
Equal to F2.
minus F1 minus F2, right? F1 minus F2. Let me admit them. Okay. Okay, so F1 minus F2. Okay, now, so F1 minus F2. Sorry. Okay, so what is F1 value? What is the F1 value? F1 is a spring one. Spring, what is the formula for spring? Spring force formula for spring? K times extension, right? F equals to Kx1. So F1 is what is the extension of F1? E plus X, right? Minus F2 is what? K E minus X. So finally you end up getting what? I write here on top. So finally you end up getting K. How much? You get the 2kx. Okay, you get 2kx. Okay. So this is your net force. So we put the net force. Okay. So what is the restoring force? F1 minus F2. F1 is K plus X. F2 is Ke minus X. Okay. So we show that. So this is simple harmonic motion, new system. Okay. Any questions from here?
No.
Oh, good. Okay. Okay, now let's continue. The main one is the next part. Next part is yeah. Okay. Okay, look at the next part. Okay, I give you 1 minute. Tell me the answer. The trolley is then released. Shows that the acceleration is trolley is given by this. Proof that the acceleration is this. Okay. Okay. So how do you prove this acceleration? We know F is what just now? F is 2kx. Okay, the net force of the system is 2kx. Proves that the acceleration is this. Okay, first you can get acceleration from here, but before that you must tell, because F is you must explain negative first. How do you get negative? Because F is what type of force? Because F is restoring, what? Restoring, sorry, my writing is bad. Restoring force, because F is a restoring force, therefore the force is negative 2kx. It's negative, you must put negative. Restoring force means should be negative because it's trying to restore back. Okay, you start to.
So the force is 2kx, negative 2kx. Is it?
Okay, so therefore negative 2kx is equals to what? Equals to ma, because it's a net force. So A you get negative what? 2kx over m. Okay, so these 2 mark, I think one for telling that is a restoring force because it's a restoring force, therefore negative. Then second is equals to ma, so you get the acceleration formula. Okay, I think it's easier. Okay, just the net force equals to ma, but you put negative here because this is a restoring force, therefore it's negative 2kx. Restoring force means it's a type of force which is trying to restore it back to the equilibrium. When the pendulum is to the right, the restoring force pull it to the left. When the pendulum is to the left, the restoring force try to pull it to the right. It always try to restore it back to the equilibrium. And that restoring force in physics always put negative. Okay, negative. Okay, so this new feature is very annoying.
Don't use this app anymore. Use another app.
But other app cannot be recorded. You can record any other app.
I don't know. We can find it. We can exploit.
So you can get me one if you have. Okay.
Okay. I will have an exploit.
Yeah. Okay. Thanks. Okay. Now you see the next question. Now, how do you answer this? 1 minute for yourself. Okay. Come on. Time. Read. A mass m is trolley is 900 gram. The spring constant is 120 Newton per meter. By comparing answer in A1 and B2, determine the frequency of oscillation of the trolley. It's a 3 marks question. Okay, they want frequency. Okay, Cambridge, if you clueless, the clue is always on top. Okay, this is your clue. The acceleration is -2 kx over m. Okay, this is your clue. From this, can you answer this? I think someone who is quite by. Can you put your handphone further away from your laptop? Okay, anyone? How to get frequency? So, A is -2 kx over m. The story starts from here. Because it's an SHM, the trolley is an SHM. Therefore, you need to compare with what? A equals to, it's a SHM, A must be negative omega squared x. Okay, so from here, you can work out what? You can find the omega squared. So therefore, omega squared is what? Omega squared is same as? Omega squared is same as what? Anyone? Omega squared is same as 2k,
Same
2km. Negative cancel. Huh? So
2K over M.
yeah, 2k over m. It's 2k over m. So omega squared is 2k over m. So because you want to find frequency, period is what? In terms of omega, 2 pi over omega. That means frequency is what? Frequency is omega over 2 pi.
2 pi.
So what's the equation for the frequency now? Omega 1 over 2 pi. Omega is what? This is omega. What is omega? Square root of 2k over
2K over M.
correct. So you need to find this frequency formula first. So because they want frequency, so you can put in your values lah. So you already successfully find the frequency formula. It's 1 over 2 pi root of 2k over m. What is the k value? K is 120 and m is
120.
and 900 gram. Yes,
900 gram.
but you must change to kilogram, 0.9, and you get the answer, the frequency. Okay, the point here is what? They will give a very unique acceleration formula for the system. You need to compare with the SHM formula. A is negative omega squared x. You need to plug out omega stands for by comparing it. Then you can find the period or frequency formula. Okay, then you get the frequency answer. Anyone got the answer for this? How much you get? 1 over 2 pi square root of 2k over m. The substitution one. So k put 120 and mass must be in kilogram, 0.9. Then you can work out the answer. Anyone got the answer? Anyone can calculate for me?
Okay, calculating now. Wait. Answer is 2.598. 2.599.
2.599. So 2.60 lah. 2.60 Earth. Okay, the answer is one side, but the important is the method. So what you learn from here? They give a unique acceleration formula. You must compare with negative omega squared x. Find the omega, then use t equals 2 pi over omega or f omega over 2 pi. Then you can work out the frequency of t. Okay, let's go to another same like formula question. Okay, go scroll down. Okay, I come back to this later. Okay, yeah, this is another type of oscillation. This is your question June 05. Okay, you see this tube, there is a tube, some mass is inside the tube. It was displaced into the liquid and it was moved into the liquid and let it go. You're going to oscillate up and down. The oscillation is found to be equals to this. A equals to A rho G M Y. Okay, so what is A? Cross-sectional area of the bottom. Rho, the density of the water. G, the gravity, of course. M, the mass of the lead shot inside. Okay, so this is the unique for this system. Okay, now first define simple harmonic motion, 2 mark. So what is it? So what is simple harmonic motion? The acceleration is directly proportional to displacement, but they are in opposite direction. Okay, so 2 mark. Okay, so next. Okay, come on, give a try. Second question. How do you find the answer for this? Show that the tube performing a frequency of this. Okay, how do you find this frequency? How do you find this frequency? So what you have to do? You have to go back to the clue is on top, the acceleration formula. Okay, what's the acceleration formula? This is the acceleration formula. From this acceleration formula, can you find the frequency formula? So if this is A, you need to compare with what? A equals to negative omega squared x. So therefore, we found omega equals to what? Anyone? Omega equals to A rho G. And this is your A is like your A, of course. Your Y is analog to your X displacement. So your A rho G over M is your omega squared. So omega squared is equals to what? Omega squared equals to A rho G. A rho G over M. So find your frequency formula. What is frequency? Frequency is omega over 2 pi, right? Omega over 2 pi. Therefore, you plug in your omega. So it's 1 over what? 1 over 2 pi. Then omega is what? This is your omega squared one. So omega is square root of A rho G over M. So you can prove this formula. Okay. So this standard, this always applies. Okay. Always applies. A need to compare with omega squared x. So you get this. So you got the idea? Okay, this is how it works. Okay, now move down. Okay, this part no need to do. I just want to show you the acceleration formula. So every system will have its own unique acceleration formula. Okay, this another system oscillates vertically, and the net force is found to be negative 2kx again. Okay, you see the part A. Show that the mass 240 gram spring is 3 Newton per centimeter. Frequency of vibrations 8. Show that mass. The frequency of vibrations 8 hertz. If the mass is 240, the K is 3 Newton per centimeter. Show that the frequency is 8 hertz. How do you show this? The MA equals negative 2kx. Show the frequency is 8 hertz. So they want what? They want frequency. But what is given? The acceleration formula is given. So how do you get the frequency formula? From acceleration. So what is A? Make this A as a subject. So you get negative 2k over m x. Because it's an SHM, A must be negative omega squared x. So therefore, omega is found to be what? Square root of 2k over m. Okay. So therefore, frequency is what? Frequency is what? Omega over 2 pi. Okay, you just substitute in. So 1 over 2 pi must square root of 2k over m will leads you to find the frequency. Okay, so this is the formula you should show. Okay, so every time the acceleration unit for the system, you must compare with the SHM acceleration formula. Take out the omega, you can find the frequency. You should get 8 hertz. Okay, make sure your k you substitute as what? Of course, this is a trap. See what's the trap? Anyone? The k. The k they give 3 Newton per centimeter. Okay, so what do you have to do? What do you have to do? Newton per meter. You have to change to Newton per meter. 3 Newton per meter, you change to 3 Newton per meter. So how much? How many Newton per centimeter? Should be 300, right? So 2 times 300. 3 Newton to x 10 per centimeter. 3 Newton. 300. 300 over the mass. Mass is how much? 0.24. 0.24, right? Yeah, 0.24. It's 240 grams, 0.24. Square root. You should be able to get 8. Do you get 8? Do you get 8? Anyone? Yeah, 600 divided by 0.2. You won't get 8. What? It's going to be big. 0.24. 2K. Spring constant is 8. 3 Newton per centimeter. 3 Newton per centimeter. Frequency of vibration mass is.
Answer is 7.95.
You get
7.96.
So you get 8 Earth. So you get a point. You must always. The acceleration just compare. Okay. Okay, class. Just in case if the class is stopped, we're going to start back at 1 o'clock. Okay. Another one lesson.
Okay.
Okay. Okay. Before we still got time. Okay. So you got idea.
So after oscillation, then we go back to AS or continue A2.
After oscillation, I definitely will get an email from TLS by today. Okay. I think probably we're going to go for AS back. Okay.
Okay. So A2 just throw it away.
A2 temporarily stopped again. Okay. But we finish off this SHM first because we are almost there. Almost there. Okay.
Chain of Cambridge.
Very uncertain. High uncertainty. Okay. So go back to the slide. Okay, now we're done with the calculation part. Okay, so now we're going to go for effects. Okay, so in SHM, you have free oscillations. It's called free oscillations. Free oscillations, a body oscillates at its natural frequency. It oscillates in natural frequency, unaffected by external force. You are not giving an external force. You don't have a machine to push it down like a baby cradle. The spring always oscillating down because there is an external force. There is a machine is fixed on top to oscillate it. If it's a free oscillation, means all the experiments you've done in the lab is free oscillations. We don't give an external force. Okay, so this is free oscillation. In exam, they will ask you to explain what is meant by free oscillations. It's a type of oscillation where it oscillates at its natural frequency, and it's unaffected by external force. These are the two marks you must have: natural frequency, unaffected by external force. Okay, the total energy of the freely oscillation remain constant. So EK plus EP is always constant for a free oscillation. Okay, the opposite of free oscillation is forced oscillation. We will come back that later. Okay, this is the free oscillation. Okay, now if there is an external force like an air resistance, what happened? The free oscillation will start to experience a system name called damping. Damping happen. It's damped. Okay, so undamped, of course, the amplitude going to remain the same. Okay, the amplitude is always the same, so it's undamped. No loss is energy, no loss of energy because amplitude remain. Okay, this is the 2 marks question they will ask in exam. Why you say this wave is undamped? Because answer is it does not lose energy because amplitude remain constant. Why amplitude remain constant means no loss of energy? Anyone? Because energy is directly proportional to what? To the amplitude squared. But half, what is the energy formula? Half m omega squared x naught squared. So the energy is directly proportional to the amplitude squared. If energy never drop, that means the amplitude must remain constant. Okay, so this is the technical proof law. If damping happens means you know that's what happened in your practical. Every experiment damping happens. You know that day you did the paper, one cardboard you oscillate, the damping is so severe. So what indication is amplitude gradually decreases, but be careful, the period remains the same. You see one oscillation period, let's say is T. After one period also it's going to be T. Period does not change. Period does not change, but the amplitude drops. This is called damped oscillation. Loss of energy, decrease in amplitude. Okay, so damped oscillation. Our practical oscillation. This one not practical. We never seen a system which never lose energy. You allow an amplitude, a pendulum to oscillate. After 1 month later, you come back. We never seen it's like it's keep on oscillating. Never happens because there is an external force. So all type of oscillation naturally is damped. Okay. Okay. Now the damping, this damping they found got the damping happens. Frequency drops. Damping, the system damping means losses energy, decreases in amplitude. Okay. It caused by what? It caused by air resistance. Okay. If I put it up, it's caused by air resistance and the frictional force. Okay. Okay. Now this damping got 3 types. This is important. Yeah, the scientists found that there is a 3 type of damping: light damping, critical damping, heavy damping. Okay. The one in your lab, I think light damping. The first one is the light damping. The amplitude drops gradually after few oscillations. The system oscillates with a decreasing amplitude. Okay, light damping. Okay, the one we never realize is this too, critical damping. You see critical damping? Critical damping, what happened? When the spring is compressed, let's say compressed, when you let it go, it immediately come to zero.
Equilibrium position.
It come to equilibrium position. That means what? You compress the spring, you let it go, it just come to the orange. Then is it oscillate? It won't oscillate. Okay, it don't oscillate. Stop oscillation. The system does not oscillate, but returns to its equilibrium position in the shortest time. That is critical damping. Okay. To do critical damping, you must have technology. Okay. Third, heavy damping. Heavy damping means what happened from the graph? You compress it, then what happened? You let it go. A spring which is compressed, if it experiences heavy damping, it takes time to